All right, the aspect of global change that we think of the most often is warming. And there are global trends in ocean warming that go along with global trends in atmospheric warming. Ocean warming is happening at all depths. So certainly the surface is warming because the air above the surface water is warming. But we also see warming happening in the deep sea, though this is a lot slower. There is enormous differences in warming among regions. So don't think just because this change is global, that means that every single area is going to be experiencing warming. It just means that overall, the oceans are warming, though there are some regions that are actually cooling. And so, for instance, there are locations off the coast of California where the ocean is cooling. And that's because of increasing winds and increasing upwelling of deep water there. If it wasn't for the drought in California, this might be an excellent place to buy property because it's going to remain nice and cool. But of course, they're not going to have any water, so. The patchiness in warming is apparent even at relatively small spatial scales. And so this image here is some islands that are experiencing warming along the south of these islands and cooling more towards the west of these islands. You can see how patchy that is. And so this is why if you have reefs that are fringing a group of islands, you can have some reefs bleach while others remain relatively untouched. It's because you have this variability in the climate in that area. But these hotspots will shift from year to year, so they're not consistent over time. And so that makes the problem difficult to predict and manage, and a reef that was fine one year may find itself bleached the next. So they are not a solution to the problem of warming. They're just something that makes it harder to predict. With these changes in ocean warming, you can expect to see changes in the distribution of animals. They're causing poleward shifts in the distribution of species. Makes sense. If you're, relatively okay temperature here in Louisiana and then suddenly it warms, maybe you're going to want to try coastal Georgia, right? Animals are moving towards cooler marine environments. Most of the changes that we're seeing currently typically occur at the edge of an organism's ranges. Here we are at the southern edge of the range of many species, and so we can expect to see a lot of those species locally die off as their range moves further to the north. Likewise, tropical species that live around the equator will likely become more common in this region because we are subtropical, and so we are slightly cooler than the equator. So an example that we've talked about is the black mangrove, which is an indicator species for climate change. The black mangrove is moving north, and right now it exists primarily at the southern tip of Florida in terms of the United States, but its distribution is moving north, so we can very well expect the black mangrove to take hold here in Louisiana at some point. And that's because things are warming here, and that's what the black mangrove likes. There are northern or southern boundaries in some cases that prevent range shifts from happening. So if, for instance, the black mangrove finds itself in Louisiana and Louisiana becomes too hot and some of that begins dying, what we would see is that those seeds from the black mangrove wouldn't really have a way of making their way around to the East Coast, right? Because we have Florida in the way. So the Gulf of Mexico can provide a northward boundary to migrations. Depends on how mobile the species is. So species have ways of distributing their young, their offspring far and wide, or in some cases the highly mobile species can move themselves like as adults. And so they have a way to avoid temperatures they don't like, but there are boundaries that exist in the ocean that may trap some species and prevent them from migrating northward. So the result of all of this is that in some locations, as species move in, we'll have completely novel combinations of species. Species interacting that have never done so before. And in some locations, we'll have regional extinction of species that we depend on, like maybe fisheries, important animals, or something like that. When you look at an individual species, there are different life stages of that species that are more sensitive to temperature. So you can't just put an adult starfish in warm water, say, oh, it survives, it'll do fine. What you have to look at is all the different life stages, especially the ones that are more sensitive to temperature changes. And those tend to be the larvae, the youngest life stages. Because of this, we might expect to see some changes in spawning due to temperature shifts. And so you might see earlier seasonal cycles for some animals as it becomes warmer earlier in the season. Or you might see delayed spawning in some intertidal species as they have to wait perhaps for the fall to spawn, for things to cool down. Despite these changes in reproductive efforts, the phytoplankton bloom timing has remained relatively constant. Phytoplankton provide food for these larvae, but the bloom of the phytoplankton relies more on the availability of light than temperature. So that means there might be a potential mismatch between the larvae and their main food source. It's unknown if the larvae, when they're hatched, will have enough food to survive, and if this will eventually hurt populations of marine and coastal organisms, but having a mismatch with your main food source is probably not going to be a good thing. And so, as an example, here is an intertidal organism, starfish. This one is spawning earlier and earlier. It used to spawn sometime in mid-July, and now it spawns in June or even sometimes in mid-May. So if that phytoplankton bloom is happening sometime in July, then those organisms that are spawned earlier might starve. As a result of changes in warming, differential warming throughout the world, throughout the globe, the ocean currents are changing. The ocean currents are being blocked because of melting ice caps. That prevents the currents from rising up from the depths to reach the poles. And these changes in currents might actually happen pretty quickly. We don't really know how the currents, how sensitive they are to a perturbation. So some of the worry in the scientific community is that there might be a point in time where the melting reaches a location that the current suddenly switch direction, or that a loop is cut off. And this might mean that the tropics continue to get warmer, that higher latitudes get colder. Unfortunately, there is a chance that northern Europe might freeze because the Gulf Stream brings warm water up into northern Europe. And if that is blocked by melting ice caps, then that water is not going to warm the coast anymore. And so that could happen quite rapidly in a period of a couple of years. That would be awful. That's actually what keeps me up at night about the global climate change conversation. You might also see sea level rise on the U.S. East Coast rapidly increase as the Gulf Stream slows, and that the U.S. East Coast and Gulf of Mexico will warm more, faster than other locations around the world. And that's because these ocean currents distribute heat. So as they slow, the changes in heat distribution will be noticeable. As they're blocked from entering certain areas of the globe, heat can no longer make it to those areas through the ocean currents. So we've talked a bit about sea level rise already because it's a definite contributing factor to coastal land loss in Louisiana. But it's important to note that sea level rise is happening all around the world. We covered the causes of sea level rise in Intro to Oceanography, but quick review, it's due to warming of the ocean, which expands the water in the basin, and it's due to melting of the ice caps. And as that sea level rises, you'll see extensive areas of intertidal habitat like marsh or beaches disappear. And that's because we prevented those marshes and beaches from crawling inland like they normally would as sea level rises. So normally what happens when human development is not happening near the coast is that as we see erosion of the marsh edge, closer to the water, then we'll have new marsh created further inland. But we create things like seawalls or levees that restrict that marsh to a specific location. So all we see is marsh loss. And this is known as coastal squeeze. Tidal areas are squeezed up against existing coastal developments. What happens when you get a coastal squeeze is that you get steepening coastal slope, and it's also associated with saltwater intrusion into the groundwater supply. And that's 100% what we're experiencing in Louisiana. If intertidal zones get more and more narrow, if these habitats are squeezed down further and further, they're less likely to support ecosystem services and functions. So we've talked about some of those, things like provision of water quality, provision of habitat and food sources for things like waterfowl and fisheries. All of that is at risk because of coastal squeeze and sea level rise.